In today's lesson, todakuita dot product, but before we get into that, todotanga tamboita iron out something we learned in our yesterday lesson. So the situation we are going to be looking at, let us say we do have an XY plane. Of course, ticha illustrate tichishandisa a two-dimensional vector. So on this XY plane, let us say we have 2 points, tina A, which is x1, y1, doma coordinates are A in space, then also tina B, and what is B again? B in the x2, y2. So this is what we are working with. Then manje, if we want the position vector of A, of course, we are just going to draw a straight line which connects the origin to A. Then what I say an arrow, which shows that this is a vector. We need the position vector of B. We do the same. That's the position vector. But tikada the displacement vector, and it which connects A and B, this displacement vector is going to be connecting these 2 points. Then we put the arrow for direction. Now if we are to mathematize what we have drawn here, the position vector of A is called OA, and it's going to be equal to, in column form, x1, y1, like that. Then the position vector of B, OB, is going to be equal to what? x2, y2, like this. What about AB, the displacement vector AB? How do we calculate AB? In our yesterday lesson, we wrote something down. Takati, following vectors are equal to opposing vector. And we tested this theory tikaona ichishanda. For example, kana chida kutsvaka AB, tikatarisa panapa tinoona kuti OA, because panapa ndi O and OA plus AB should be equal to OB, because OA na AB zviri kuteverana zvofanirwa kuti pa the opposing vector, which is OB. Saka if we are to do the same panapa, tichaona kuti if we write this statement, it's going to be OA plus AB is equal to OB. Kureva kuti eventually tikaendesa OA kuside uku, tichasara tina AB is equal to OB subtracting OA. This is correct, and it works perfectly kana tichita ma two-dimensional vectors. What if we include a third dimension, which we are going to call set? What happens? Because to represent ma vectors in 3 dimensions, tishandisa ma graph, it's nearly impossible unless we are using computers to do that. Tirite guys, also to understand vectors in that sphere, it's going to be difficult. So we have to learn another way of finding a displacement vector, and this other way, it's written simply as a displacement vector is equal to the destination point, kana kuti destination position vector, ngatiti destination point subtracting the source point. And this is very important. I'm going to bracket it like this. You have to put it in your notes. A displacement vector is equal to the destination point subtracting the source point. Saka, let us say we want to apply this to ab. Kana tichiti ab tiri kuti tiri kubva pana a tichienda kuna b but in the direction of b, ndozoreva kuti ab. Saka tiri panapa a unoyu ndipo kwatiri kutangira, saka ndo yatiri kuti source point, kwatatangira the source. Then b unoyu ndo kwatiri kunogumira, so is the destination point, kwatiri kugumira. What this is telling us is ab, which is our displacement vector, is equal to the destination point anova b, but isusu manje b uyu takumunyora as a position vector, saka tichati ob, the destination point ob, subtracting the source point which is a, we write it as oa, a position vector. Saka from this trukonoti panapa, using this sort of theory, kana kuti theorem, you can call it that, principle, following vectors are equal to opposing vectors, and cannot following vectors are equal to the opposing vector. Taona kuti ab eventualizes as ob minus oa, but if we use this simple statement, tinoona kuti ab again is going to be ob minus oa. What do I encourage? So long muchishanda nema 3D vectors, this is your way to go. So this is what I wanted to add upon from our yesterday lesson. Let us now look at today's lesson. In today's lesson, tichada kuita emphasize more on the dot scalar product, but chatiri kunyanya kuda kuita broadly, toda kungoita ma arithmetic operations anechekuita ne ma vectors. Saka let us start with addition and subtraction of vectors. So this is basically what we did in our yesterday lesson. Saka treat it as a revision. Addition and subtraction of vectors. As we are doing this, I want to give you a piece of advice. Mathematics cannot be learned passively. It will be an illusion. Saka mkwanise kudzidza maths nekutarisa ndichiita paboard. Munodzidza maths through practice. So I would encourage you, whenever I'm doing a question, kuti you pause the video, you attempt the question, you unpause to see if your answer and my answer agree. That is the best way of learning. So in this particular example, we are given two position vectors. Taudzwa kuti oa iri equal to 3 minus 2, 6. So it's 3-dimensional, x, y, z. Tikaudzwa kuti ob iri equal to minus 1, 3 minus 2. That is what we have been told. Saka for our number 1, toda kuziva kuti oa plus 3ob inotipa chi. Saka of course we are going to substitute oa into 3 minus 2, 6 plus we have 3 panapa, ob indian, ob indi minus 1, 3 minus 2, like that. Saka this part manje brings us back, kana kuti introduces, but this was taught in O level, so it brings us back to scalar multiplication. Yatakati, the outer term is going to multiply every term inside the vector, inside the brackets. Correct panapa? This is 3 minus 2, 6. We are going to add, you can put it like this, or you can do it mumsoro. 3 multiplying minus 1, 3 multiplying 3, 3 multiplying minus 2. Like that. Saka 3 inopinda mkati mema brackets a vector, you multiply every term. That is scalar multiplication. Correct panapa takutichi 3 minus 2, 6 plus, what is 3 times minus 1? The minus 3. 3 times 3, 3, 6, 9. The 3 3 times minus 2 the minus 6, like this. Then tadaiso, of course, we are going to apply zvatakadzidza kuma matrices. We know correspondency, kureva kuti 3 iyo ichaedda minus 3, minus 2 yoedda 9, 6 yoedda minus 6, like this. So this then is equal to what? This is equal to, tikati 3 plus minus 3, we know kuti plus na minus zvikasangana zvinoita chi? Zvinoita minus. So this is basically 3 minus 3, which is 0. Or you wanted me to do it 3 minus 3, because pasangana plus na minus, apo it's simply, it's minus 2 plus 6, but to make life easier, tokona kutanga tanyora a positive, yova 9 plus minus 2, which just becomes 9 minus 2. Then apa, it's 6 minus 6, because pasangana plus na minus, making our final answer 0. Minus 2 plus 9, or 9 minus 2, ndian, the 7. And of course 6 minus 6, the 0. So our answer is 0, 7, 0. That is the vector we are getting there. If there are any questions, please ask in the comments, but I think I have explained it to full satisfies. Okay, we also do have a number 2. So let me remove this part to usher us into this number 2. Saka for our number 2, iri kuti 2OA minus 3OB. Saka of course 2 multiplying the vector 3 minus 2, 6, subtracting 3 multiplying the vector minus 1, 3 minus 2, like this. Maybe let me put an equal sign perhaps. Saka this is equal to 2 which multiply every term inside the vector, 2 times 3 in the 6, 2 times minus 2 in the minus 4, 2 times 6 in the 12, like this. Then towataisa this negative panap ngaingo chingogarai matoisa. Of course we could have said minus 3 times. I'm going to do it as a method 2, but I think it best kuti mugare mangoisa minus. Then makuchi multiply 3 in times minus 1 ichakupa ichi minus 3, 3 times 3 yokupai 9, 3 times minus 2 yokupai minus 6, like this. Saka this then is equal to, tikaita correspondence panapa, 6 minus minus 3 in over 6 plus 3, minus 4 minus 9, tungoenyora yakadaro, 12 minus minus 6 in over 12 plus 6. So panosangana minus na minus, panoita plus, this is the same which happened pana 12 minus minus 6. Saka allow me kudai so. So our final answer is eventually going to be, what is 6 plus 3? 7, 8, 9. What about minus 4 minus 9? 9, 10, 11, 12, 13. Second minus 13. And then lastly 12 plus 6, 6, 7, 8, making it 18. That would be our answer. Now let me take you back to Shoma to what it could have been had we done it differently. What we could have done as a method number 2, but I don't encourage it, was this. Of course, we multiply 2 into the vector, towana 6 minus 4, 12. Then panapa, instead of freezing minus vataitapa, then multiply 3 into the bracket to 1 in this particular bracket, we can actually multiply minus 3 into the bracket. Kana kuti multiply the vector, the position vector, by minus 3 instead of 3. So if we are to do that, tingeta kuti minus 3 times minus 1, it gives us 3. But what happens is, the moment you have to multiply what is inside the vector bracket with minus 3, zvoreva kuti the operator which is going to be joining our vectors is now a plus. Saka because of this technicality, that's why I don't encourage you to do this. But I'm just doing this kuti muone kuti it's possible. Uye kuti muone kuti it arrives at the same answer. But it's safer to freeze the negative. Atenda panapa 3 over multiplier into the vector. Then solving it would be much easier. Minus 3 times 3 would have been minus 9. Minus 3 times minus 2 would be 6, since we are multiplying negatives. Then tikauya panapa, this could have been 6 plus 3, 7, 8, 9. Minus 4 plus minus 9. Remember, panosangana plus na minus panova minus. So minus 4 minus 9, 9, 10, 11, 12, 13. Then 12 plus 6, of course, 18. Mukakombea maanza edu, munoona kutaka akafanana. Saka pick your poison amazangu, but I encourage you kuti muite the first way. You freeze the negative, then you multiply just by the scalar 3. So this is just a rough revision of addition and subtraction of vectors, which we did. So I would encourage that you practice these questions on the go. Let us now get into the dot and scalar product. Saka, this is mainly what we wanted to learn today. Toda kuita dot scalar product. That is what we want to learn. So what is this dot scalar product and how do we apply it? Chekutanga, as a definition, tofunga kuziva kuti a dot product is the sum of products of corresponding directions. So this is just a bookish definition. It is of less material. Chakakosha kuziva kuti tiri kumborevei. So when we say a dot product, chandoda kuti muite carry with panapa kuziva kuti this is going to be a sum. Saka yava isomorphism, kufambidzana nekunzwisisana kunoita multiplication ne addition. So multiplication and addition, they are isomorphic. Pakuti in most cases they are related. We also see the same happening with subtraction and also division. So a dot product is going to be a sum, but a sum of what? It's a sum of products. It being a sum of products, they should be of a corresponding direction. We are going to add upon this in a moment. Okay, let us put in an example. Let us say, so this is going to be our first example. If A, and it's a vector, A is equal to this 3-dimensional vector A1, A2, A3, and we have another vector B, which is also equal to B1, B2, B3. Kana tichida kuziva the dot product of these two vectors. Let me write it down. The dot product of A and B how do we express it? Tinongoti A dot B. Dot yakamirira multiplication. But kana tiri kumavectors hatishandisi that traditional multiplication sign, that x. No, tinoshandisa a dot. So the dot product of A and B, tirikuti A dot B. So A dot B is going to be equal to, pana A ito wataisa vector yacho A1, A2, A3. pana b toisa dot yedu, remember pana b, b1, b2, b3, like this. And this is then equal to what? Sapanapa pachashanda correspondence because atiri kuti ma products in our definition kungo multiplier a1 times b1, so it's a1 b1 plus a2 b2 plus a3 b3. This is the dot product. Zvinenge zvatopera. So it's not difficult, it's straightforward to answer the principle of correspondency. Zviri kutevedzana kana zviri kuenderana ndo zvino multiplier, then we find the sum. Okay, let us solidify this with the second illustration. Let me use a different color for the second one to set it apart. So in our second illustration, we can have a situation which is now more practical to the mathematics you are going to be doing. Let us say it's x1, y1, z1. This is a vector we have. We need a dot product with another vector, x2, y2, z2. Remember, we can use any letter for x, y, z, and in most cases it's I, J, K, as we illustrated earlier in our yesterday lesson. So this is then equal to what? x1 is a multiplier x2. It's a sum. y1 your multiplier y2. z1 your multiplier z2. So this is not in any way difficult. Now, as is our tradition, we are going to have, in this case, 2 practice questions, then we conclude our lesson. This is going to be our first practice lesson. Saka, we are given OA, it's a practice question. This position vector, it's 3 minus 2, 6. We are also given OB, and this is minus 1, 3 minus 2, like that. Trikuda kutsvaga the dot product, so it's OA dot OB, which is going to be equal to, we are going to multiply things which are corresponding, but let us do this first. 3 minus 2, 6 dot minus 1, 3 minus 2. So this is equal to 3 multiplying minus 1 plus minus 2 multiplying 3 plus 6 multiplying minus 2, like that. 3 times minus 1 minus 3, minus 2 times 3 minus 6, but plus na minus, of course, osangana chingoti pa minus, so it's minus 3 panaba minus 6. Then knowing kuti 6 times minus 2 ndi minus 12 plus na minus, saka panapa ingayadai so. So it's minus 3 minus 6 minus 12. And this is equal to, panapa it's basically 6, 7, 8 to make 18, 18, 19, 20, 21. So the answer is minus 21. Saka, that is the answer we are getting. I want you to pay particular attention, especially for this negative sign. It means something. We are going to be interested with the angle between vectors, the angle between position vectors. And that negative on the dot product is going to give us a hint on what we expect the angle to be. That is going to be the last concept we learn, so stay tuned. Let us go to the second practice question. This is going to be our question. The position vectors of A, B, and C relative to a fixed origin O are, saka panapa OA iri equal to 2, 1, 3. Taudzwa futi kuti OB iri equal to 3, 0, 2. tikaudzwa futi kuti OC iri equal to 145. So this is what we are told. Part 1 iri kuda kuti titsvage OA dot OB. Saka OA dot OB, it's going to be, what is OA 213 dot OB 302. Now, zvoreva kuti 2 multiplying 3 plus 1 multiplying 0 plus 3 multiplying 2, which is going to be 2 times 3 is 6, plus 1 times 0 is 0, plus 3 times 2 is 6. Correct, our answer is 12. Like that. Then let us now look at the second part. Second part, AB dot BC. Like that. Saka tichada kutanga taziva kuti AB ndiyani tozoziva kuti BC ndiyani. Saka AB andika iri equal to, remember that statement tinoti destination point minus source point. Saka panapa B ndo kwa kuri kuperera vector, kureva kuti inenge iri equal to OB subtracting OA like this. And panapa mamuchigona kuti consider, just to communicate your working better. Saka panapa this is equal to OB 302 subtracting OA, which is 213. This is equal to 3 minus 2 ndi 1, 0 minus 1 ndi minus 1, 2 minus 3 ndi minus 1. Saka this is AB. Okay. What about BC? So we now want to consider BC. Now considering BC, BC iri equal to kuri kuperera vector OC subtracting kwaratangira OB. Saka OC taudzwa kuti ndi 145. This is subtracting OB anova 302. So this is equal to 1 minus 3 ndi minus 2, 4 minus 0 ndi 4, and 5 minus 2 ndi 3. So this is going to be BC. Now back to AB, BC. Therefore, AB dot BC iri equal to AB taona kuti ndi 1 minus 1 minus 1 foot dot BC taona kuti ndi minus 2, 4, 3. Like this. So this is going to be equal to 1 multiplying minus 2 plus minus 1 multiplying 4 plus minus 1 multiplying 3. So this is 1 times minus 2 into minus 2, minus 1 times 4 into minus 4, then plus minus 4 and gangur minus 4, then panapa minus 1 times 3 into minus 3, plus minus minus 3. So we have it as minus 2 minus 4 minus 3, which of course is going to be equal to 4, 5, 6, 7, 8, 9 minus 9. That is what we are getting. So Kanarma position vectors is quite straightforward, but wakakupa ima displacement vectors, you have to evaluate the displacement vectors first before you can find the dot product. Now let us move on to the last part of today's lesson, where we are going to find the relationship between the dot product and the angle between vectors. So dot product is used to draw up conclusions, to draw up a conclusion on the size of the angle. size of the angle between two vectors. Size of angle between two vectors. Okay, what do we mean by this? There's a table I want to show you. You should also have that table in your notes, which is going to summarize what we mean kana tichiti pane a relationship between the dot product and the angle between two vectors. This is the table we are talking about. Saka kana dot product yedu iri negative, zvinoreva kuti angle between the two vectors is going to be obtuse. And kana tichiti obtuse angle, remember, obtuse angle, tiri kuti this is the angle theta, which is going to be greater than 90 degrees, but at the same time lesser than 180 degrees. That is what obtuse mean. Then kana dot product yedu iri 0, kureva kuti isina a sign positive or negative, zvoreva kuti our angle is right angled 90 degrees. Then kana our dot product iri positive, zvoreva kuti we have an acute angle, and I want you to remember that an acute angle is basically the angle theta, which is greater than 0 degrees but lesser than 90 degrees. What's important to remember is 90 degrees and 180 degrees in this context, they are neither obtuse or acute. They are a right angle and angles on a straight line. So this is going to be important, especially in the lessons which are going to come. Patinenge takuda kuita determine the angle between two position vectors. You are going to need this knowledge to understand that, and I think it's fairly easy to understand. Our next lesson is going to start from the magnitude of vectors. Ndo zvatinenge tichiita in our next lesson. Thank you for watching. I hope you learned something. If you have learned something, may you please consider subscribing, liking, and sharing. If you want to join our private class, you can WhatsApp us on these numbers: +263 71 521 3310. Thank you and take care.